The last section in our quadrilateral unit really just tells us how all of these relate to each other. So I have the definitions in these boxes, and we're going to just try to look at these shapes and decide which ones fit the definitions. This first shape is a classic parallelogram. And we've got what we would call a rectangle, a rhombus, a square, a trapezoid, an isosceles trapezoid, and a kite. But it's not that simple because there are sometimes numerous shapes that fit into the definition. For example, on a parallelogram, obviously our parallelogram fits that, but what else has both pairs of opposite sides parallel? This rectangle has both pairs of opposite sides parallel, which means a rectangle is a parallelogram. It's a special type. And a rhombus has both pairs of opposite sides parallel. And a square has both pairs of opposite sides parallel. The rest of those shapes, maybe only one pair or not even any pairs. So those are the 4 shapes that we've studied that are classified as parallelograms. So rectangles include the classic rectangle because it has 4 right angles. What other shape has 4 right angles? Our square does. So we can also include a square as a rectangle. A square is a rectangle. Then in the rhombus category, we've got a classic rhombus, a quadrilateral with 4 congruent sides. Are there any other shapes we've studied that have 4 congruent sides? The square does. And so both of those are considered to be rhombuses. The square is just a special type of rhombus. And then all the way down here, a square is a quadrilateral with 4 congruent sides and 4 right angles. And that is really the only way you can draw a square. It's a pretty specialized classification. On the other side, a kite. A quadrilateral with 2 pairs of consecutive sides congruent, but the opposite sides are not congruent. So we know that this is our classic kite. And the way they define it just excludes all of those other shapes. This would be the only thing that fits our definition of a kite. And a trapezoid, a quadrilateral with exactly 1 pair of parallel sides. It can only have 1. Some people would consider a parallelogram a trapezoid if they didn't have that exactly 1 in there, because it does have 1 pair of parallel sides. But our definition is that it has exactly 1, or only 1. And of course an isosceles trapezoid, also considered a trapezoid because it has 1 pair of parallel sides. And then this special type of trapezoid, the isosceles trapezoid, has congruent legs. And now that we have all of those filled in, I want to talk about the family tree. I like to think of the parallelogram as the grandfather of all of these others, and so the parallelogram has descendants of rectangles and rhombuses, and they inherit all the properties of a parallelogram. And when a rectangle and a rhombus fall in love and get married and have a baby, it is a square because the square has the traits of the rectangle, the 4 right angles, and the rhombus, 4 congruent sides. It inherits the properties of mom and dad and grandpa parallelogram. The kite is just kind of in its own family, but the trapezoid has a little bit of a family tree. Some trapezoids wind up being isosceles, just depends on if their legs are the same length. And so we know if we were going up the family tree, you inherit all of the properties of your ancestors. I'd like you to add the word always with an up arrow, because I could say that a square is always a parallelogram, a rectangle is always a parallelogram, a square is always a rhombus. If you're going up that family tree, you always inherit what comes from your ancestors. And then the word sometimes with a down arrow, which just tells us that if you are in the parallelogram family, then you could sometimes be a rhombus. Or if you're a rhombus, you're sometimes a square. Some rectangles are squares. So if you're coming from the top down, we can say that some parallelograms are squares. Coming down the family tree is a sometimes thing. So parallelograms sometimes have the properties of a square and sometimes have the properties of a rhombus. And that's true on the trapezoid family tree too. Up is always, isosceles trapezoids always have the qualities of a trapezoid, and trapezoids sometimes have the qualities of an isosceles trapezoid. And then one last thing I'll mention is that these families never mix. And so if we were asking, is a square an isosceles trapezoid? If we're going back and forth, it's more of a never. Isosceles trapezoids never inherit rectangle properties. They might have something in common, but there's no direct connection there, other than that all of these shapes live in the quadrilateral family. So I like to refer to this as the quadrilateral family tree.